guys, this is Mrs. White.
And I'm Mrs. Hurst.
And the two of us will be performing and videotaping our flip lessons for the semester. Sometimes it'll be both of us, sometimes it'll just be myself, sometimes it'll just be Miss Hurst, and sometimes we'll have some guest appearances. But since this is your first flip lesson, I do want to go over a little things that might help you throughout this video. First off, because it's a flipped classroom, this is for you guys. So if you need to pause at any time, please pause the video. If you need to rewind because you missed something or you just didn't understand what we were talking about, please take the time to rewind. And if you have any questions, please star by your notes so that you can bring them to class tomorrow or the next day, and we can go through it as either a class with your peers or even with myself. So that's the beauty of flipped class. You can do it at your own pace. So here is our first lesson today, and we're going to be talking about section 1.2, points, lines, and planes. And Miss Hurst is the definition guru today. She is going to start off our video.
Alright, so hopefully you have your pencil and paper ready. We're going to write down some stuff. And again, write down whatever it is that you need to write down for yourself to get this. We're going to start off with some undefined terms. Now, we're going to give you definitions for them, but they're made up based on agreements. So, to give you the technical definition of an undefined term, they're words that have no formal definition. So instead, there is an agreement about what they mean. In geometry, the words point, line, and plane are considered undefined. Now, before we get to those words, we're going to talk about these two words, collinear points and coplanar points. Okay. Now, the prefix co, we've talked about with cooperation, with collaboration, that co, C-O, stands for with. So if we're talking about collinear, we're talking about with a line. Points that lie on the same line. Coplanar would be points that lie on the same plane, or lines that lie on the same plane. Okay? If you need to pause this at this point in time so that you can write the definition down because I'm talking too fast for you, feel free. If you're good, go ahead and just keep watching. Okay? So we're going to start with our first definition, point. A point has no dimension. You may or may not be asked about this later, but just understand that there's no dimension. It doesn't take up space or anything like that. A point has no dimension. It's represented by a dot, and it's always labeled by a capital letter. For example, this guy right here is point A. So if I wanted to name him, I would say he is point capital A. So please don't interchange capital A with lowercase a. They mean totally different things in geometry. We could also do something like this. If I had another point and named him B, he would be point B. Okay? So I'm going to move these guys out of the way so that we can talk about our next definition. Our next definition is a line. Okay? A line now has one dimension, and it extends without end in both directions. Notice the arrowheads at both ends. Okay? It has an infinite number of points. So we've picked out point M and point N, but there are really an infinite amount anywhere between M and N and on the other sides of them. So we're going to talk about how to label a line. You can either label it with the lowercase script letter, which I've covered up with my arrow. This guy right here is a lowercase L. So we can name it with the lowercase script letter at the end of the line, or you can name it with 2 points. Notice that I said 2 points, not 3, not 4, but 2 points that are on the line and a line symbol above them. For example, this line, one of the names I could give it is line L. Okay? Another line I could give it or name is MN, and I said with the line symbol above it. This is the line symbol. Make sure you put the 2 arrowheads so we know we're not talking about something else. Now, I could also say that this is line NM. Let's say I put another point on here. We'll call it point P. Now let's introduce a few other ways that I could name this line. I'm just going to say them out loud. You can write them down if you want to. We could say this is point M, or line MP, so we could go MP. We could go backwards, PM. We could say that this is PN or NP, but I cannot say that this is line MPN, okay? Because remember, up in the definition, we said we're going to name the line with 2 points, so this is not acceptable. Now, again, on the same lines, we can't use just one letter unless it's that little script letter at the bottom. So this is not line M, or line P, or line N. Okay? Again, at any point in time, if you need to stop, go ahead and hit pause so that you can get the rest of this definition down before I make it disappear. All right. If I can have my lovely assistant move everything over.
Sure.
And then we're going to go ahead and talk about a postulate. Now, a postulate is a fact. Okay? It's something that, as mathematicians, the community agree this is true. It's always going to be true. The line postulate says that through any 2 points, there exists exactly one line. So any point anywhere connects to any other point anywhere else. Okay? All right, so let's talk about the definition of a plane. A plane has 2 dimensions, so we're getting bigger in our dimensions now. Your piece of paper, your walls, your floor, your ceiling, those are all planes. Okay, they do go on forever, but we can't exactly draw forever on our paper, so we're just going to outline it by a 4-sided figure. So how to label a plane? With the capital letter. Now, the capital letter that is not a point. So if you look at your picture down here, our capital letter that is not a point is Q. Okay, he's bigger than the rest of them. He's not always going to be bigger than the rest of them, but he doesn't have a dot next to him, so he is not considered a point. We can also name him by using 3 non-collinear points in the plane. For example, we have points X, Y, and Z. Notice that those 3 points, X, Y, and Z, are not on the same line, so they are non-collinear. Okay? So I could say that this is plane Q. I could say that this is plane X, Y, Z. Or you could rearrange those letters in any fashion you want to. Typically, I like to go with alphabetically in order, so that's why I'm going to choose X, Y, Z as opposed to Y, Z, X. So these are the 2 ways I can name this plane. There's also a plane postulate. Just like there was a line postulate, there's a plane postulate. So this is what this guy says. Any 3 non-collinear points, again, non-collinear, just like the way we were supposed to name it, is exactly one plane. Okay, so I can have a plane through any 3 non-collinear points. So this right here, not going to make me a plane because they are what? They are collinear. This is a straight line. But if I add another guy right here, these 2 points and this guy, non-collinear, I can make a plane. And I do have 3 non-collinear points, and I can make a plane over here.
All right, now that you guys are experts, oops, wrong way, experts on all these definitions, let's go to an example. So this example right here has a plane that's drawn out, so a flat surface, plus we have 2 different lines. The line that is completely solid means that entire line that extends forever with the plane, all these points will be on that plane. Our other line is a little bit different. It's starting off the plane and coming through and only meeting this plane at one point, at point N, and then this dotted line represents that it's kind of like shooting out the back. Okay, so really the blue line is all on the plane. The red line, the only point that is on there that meets and intersects with the plane is point N. So what I would like you guys to do right now, you need to draw out this example and then hit pause, because I want you to take the time right now to name all the different points, lines, and planes in this given diagram. Once we come back, I'll go over there's different ways to name all of these, so we'll make sure that you know how to do this correctly. All right, so there are tons of points on this diagram, this example. So let's just start. We have point M, point N, point L, point O, point P, and finally point Q. The ones that you should have not listed on there are S, R, and T, because those 3 actually name the lines and the planes, like Mrs. Hurst explained. All right, so please don't include those with your points. Lines. There are 2 different lines. So let's start with this line in the blue here that I outlined. One way you could name that is writing out the word line, and then our script letter S. Since that's not a point, you can write it that way. Another way is picking any 2 points. We have Q and an L. So to pick any 2 combinations, for instance, and Q is one way, and don't forget the notation above. You could have put an LN. There's other ways to write this line. So we have QN. You can flip that. You can flip it NL. And you can also do QL or LQ. So those are all different ways to name that first line. This second line in this red that I'm outlining, okay, the first way we can name it is writing out line T, okay, because T is not a point on this line, but it's a script letter. Or we have O and N is also on this line, and P is point. So we can pick any of the three combinations. OP, okay, we could put NO, we could also put PN, and then you can flip these all around to do PO, ON, and NP. But make sure you're using this notation, the top of the, above the points, you need to have that line symbol, and you'll see why on the next slide. And there is only one plane up here, so there are a couple ways you can name this plane. Remember, you have to write out the word plane, and because R is not a point, it doesn't have a dot next to it, that is one way to name this plane. Another way to name this plane is picking any 3 points, okay, that are on this line. So I'm going to pick the points plane M-O-N. M-O-N, okay, are 3 points that are on the plane that are non-collinear. So, one way that you cannot name this is by the points plane O, N, and P. And why can't you name it like that? Points O, N, and P are collinear points, so they're all on the same line. And so remember in the definition, they have to be 3 non-collinear points. So any of the 4, but they have to be non-collinear.
So I know what you're thinking right now. What about points L and Q? Can they be part of the name for the plane?
So, good question. Points L and point Q. Okay, can we name them within our word? No, points L and Q are not on the plane. Okay, they are labeled off the plane, so you're not able to use those 2 points either. Lastly, okay, what I want you guys to do, extend the page, sorry. There we go. All right, so thinking about all these in the real world, there are points, lines, and planes everywhere. And it's coming up to football season because it's the fall right now. Let's think about where are points, lines, and planes on a football field. So what I would like you to do is name some examples and bring them into class so we can have a little discussion at the beginning of class about where you can find points, lines, and planes on a football field. All right. More definitions.
All right, so this time these are defined terms. So they actually have a definition and they can be described unanimously using known words. Now, first of all, I'm going to tell you a really true story. So there was this guy, his name was Ray, and his favorite bands, wait for it, was One Direction. Okay, now here's why that's a really awesome story, because the definition of a ray is that it goes on infinitely in one direction. Okay, so like I said, a ray is a line with one endpoint, and then it extends infinitely in the other direction, in one direction. So if we look at these 2 rays, we'll start with the one I'm highlighting in green. It starts at point C and goes on forever, but it passes through what we've picked out to be point B. Okay? Now, that's important when we start to label these. A ray is labeled by the endpoint first, and then a point on the line in the direction it extends. So if I were going to label this one that we just highlighted in green, I'd have to start with the letter C, since C is the endpoint. It goes through point B, so we're going to write that down next. The notation for this, which is why it's important to distinguish between the line we were just talking about, is I'm going to draw a line but with one arrowhead, and that arrow is always going to be on the right. So let's talk about this other guy that I'm highlighting in red. Okay? He starts at point D. So if I'm going to name him, he's going to be point D, and then it goes through point E. And I'm still going to draw that one-sided line with the arrow going to the right. Okay, well, since we're talking about rays, before we get on to this line segment over here, we're going to talk about opposite rays. Now, opposite rays are 2 rays who share the same endpoint but extend in opposite directions to form a line. So we've already talked about a line. You know it goes infinitely in both directions. So looking at this guy, he goes on in both directions, so we could easily just dismiss the fact that he's opposite rays, but since we asked the question and posed the definition, we want to figure out what's the common endpoint. Well, the common endpoint here is x. So if I'm going to name the two opposite rays in this picture, we're going to say that x goes forever through point W, so that would be ray x W, and it goes forever through point Y, so that would be ray x Y. So these two are the opposite rays in this picture. All right, let's go back up and we'll talk about what a line segment is. Okay, so a line, oops, too far. A line segment is a line with two endpoints. So it stops and it starts. And it consists of all points between them. So just like a line has an infinite number of points, so does a line segment. It just has a smaller amount of infinite points. So line segments are labeled by the endpoints in any order. By the way, this is a typo, but if you guys find any other typos, we might praise you and give you some sort of reward, maybe. Okay, so keep your eyes peeled. So line segments are labeled by the endpoints in any order. So looking at this picture that we have over here, it starts at point A, if we're used to reading from left to right, and ends at point B. So those are my endpoints. It stops, it starts, it has an actual measure. So I could call this AB, and the symbol we're going to put on top of that is just a line, no arrowheads, no dots. But if we read from right to left, this could also be point B first and then point A. It still represents the same segment. So you can name segments both directions, any order you want to.
All right, let's do some practice and make sure that we understand all those definitions that Mrs. Hurst just went through. So here's an example of two lines that intersect with 5 different points. Please go ahead and draw out this example. Here are 3 questions that we're going to answer. So right now, if you could take the time to pause, draw this out and see if you can answer it so that when we come back, you can check your answers and make sure that you got them all correct. All right, so the first question says, what is another name for GH? And looking at the notation, it's a line segment. So this is line segment GH. So remember, just like Mrs. Hurst said, you have to use the endpoints. Well, the endpoints are G and H. The only other way to name this line segment is flipping it and reading it HG with the line segment symbol above it. No other option for this question. Second question says, name all the rays with endpoint G. So since we're naming it with an endpoint G, G has to be which letter? The first letter, because the endpoint goes first. So we'll just start with the GH one. Now, since we're talking about the ray going from G to H, we have to use the ray symbol above it. That's one ray with endpoint G. Another ray starting at G and going in the direction of I in the green would be ray GI. Third one, going from endpoint G and off in the direction of E, you have ray GE. Okay, and lastly, one more. Okay, starting with G and going towards F. Okay, ray GF. There are 4 different rays with all that same endpoint, just going in different directions. Make sure you are starting each one with the letter G. That's important. Last question of this example says, what are 2 examples of opposite rays? So remember, Mrs. Hurst said opposite rays have to be on a straight line. They do have a common endpoint. So here's a straight line right here. Okay, in blue, we're going to use this one to identify the opposite rays. The common endpoint in the middle here would be G. So I can say one ray is GI. So it goes from G and in this direction. The opposite would be from G to F. Okay, this is one pair of opposite rays. Same endpoint, different directions on a straight line. The next and final example of opposite rays would be using this other line that I've just highlighted in red and finding that common endpoint in the middle, G, and we can name one ray going from G to H, direction this way. okay? Going in the opposite direction, starting at G, we can end up going through E, okay? These both form a straight line, GH and GE. So these are both opposite rays. Now, just make sure, and I can't stress enough notation-wise, line segments, you know, with a straight line, a ray with one arrow, or a line with double arrows. Please, please, please pay attention and, you know, the examples in your textbook when we do practice or on tests or quizzes to see what they're actually talking about. All right.
Okay, just a few more definitions.
We love definitions.
These are the last slides of definitions, at least I think I promised. Okay, so we're going to talk about intersections and what happens when two lines intersect, what happens when two planes intersect. Okay, now an intersection is somewhere where, let's look at the definition, it's the set of points two figures have in common. Now that's kind of a weird definition. We know intersections from driving, from getting to a crosswalk, from looking at a stoplight, a stop sign, that kind of stuff. It's where two things meet, all right? Now, the intersection postulate for our lines, this guy right here, probably makes most sense. You've seen it before in algebra when you were solving systems, okay? Two lines intersect at one point. They either intersect at one point, they don't intersect, or we might have two lines that share the exact same space and they intersect everywhere, okay? But we're gonna focus in geometry on this type of intersection, okay? Now, what we just circled in red, I have two lines, just like the example you just looked at with Mrs. White, and these two lines intersect at one point. They intersect at point G, okay? So if we asked you where's the intersection, your answer would be point G. Now, intersecting planes postulate. Before I show you the definition, I'm gonna show you my two planes. So if you wanna look at what I'm doing at the bottom corner of your little screen, I've got two planes right here. They look like little yellow pieces of paper, but they really are planes, okay? So what happens if I cross them? Well, if I cross them, they intersect at what looks like the start of a line, okay? So they actually do make a line. Now, these are just represent planes. The planes actually go on forever. And we'll look now at the formal definition of this. Okay, so our intersecting planes postulate says that two planes intersect to form a line. Now, based on the picture, it's kind of hard to tell. It looks kind of funny. Your eyes play tricks on you all the time. But what's happening here is these two cross, just like the pieces of paper I just held up, at this line right here, right? Now, that line does really go on forever. The planes really do go on forever, even though we can only draw on a piece of paper. So we're just drawing a representation. We're going to do a couple more examples with this. Hope you're ready.
All right, this is the last slide and last examples for today. We're going to look at this three-dimensional figure. There are 6 different planes here that are all intersecting. So take a moment to pause and draw out this three-dimensional shape. If you need help, I am a horrible artist, just so you know. I am a lefty, I screw up things, but here's a simple way to draw this box if you need to. Just start off with a simple plane, then overlap another plane, and then connect the corners like so. And I always use dotted lines, but you don't have to, okay? And then go ahead, and all the letters are points on the corner, okay? So all these corners of the boxes are points that you can label. So mine's not that great, but it gives you a general idea how to draw this box, okay? So go ahead and take the time to draw this out. And here are 3 final questions we're going to use about intersections and how to identify planes when there's more than one plane in an example. So what I always tell you guys to do in a three-dimensional shape or a shape that has more than one plane, more than one line, is to practice highlighting and finding and identifying what they're talking about. The first one asks about the intersection of 2 different planes. Okay, so what I'm going to first do is highlight the 2 planes they're asking about. So I'm going to pick the points A, D, and C, and I can see that these 3 points are on the top of the box, this plane here that I highlighted, which also includes point B. Okay, so this is the first plane. The second plane is plane B, F, and G. So looking and connecting here, it's the side of the box that also includes point C. So highlighting this here, noticing the intersection where both of the colors overlap is this line here. Remember, just like Ms. Hurst said, two planes always intersect to form a line, so your answer needs to be a line. It's not a point, it's not another plane. So this line here, the intersection would be the line BC, okay? And remember notations, the line symbol goes above. All right, I'm gonna erase this so we can see our next question. All right, what are the names of two planes that intersect at BF? So we're gonna practice naming the planes. Well, let me highlight the line BF first, okay? So we're gonna look right now at the two planes that are gonna meet at this line. They both have to contain B and F because that's on the line. Here's the first plane that I'm gonna highlight. Okay, when we name a plane, remember, pick 3 points that are non-collinear. Well, there's 4 points, A, B, F, and E. So any 3 in any order, and I'm just gonna say A, B, F, is this first plane here in the red. You could have used E in your notation if you would like. The second plane that intersects that also contains BF is the side here with the points B, C, G, and F labeled, okay? So pick any 3 points, plane, let's do BCG, and that names that plane. If you have questions about how you named it or if you're not sure if you named it correctly, just please ask me in class tomorrow. Okay, and the last and final question of the day of your first geometry lesson is what plane contains points DHG? So looking here, D, H, and G, if I connect these, that represents the back of the box. That also includes point C. So pick any 3 of those points, and I'm just going to pick the points DHG since that's what they gave us, and that's how you name that plane. But remember, you can name any of the other 4 points in any, or the 3 points in any order. So this is your first official flipped lesson, and we hope you guys enjoy it.
Yay!
Yay!
Okay, so we really do hope you enjoyed your first flipped lesson. Now, as we talked about in class, you guys need to make sure that you're writing down at least 1 question every time you watch one of our lectures. So that question can either be a confusion question. There's something you watched today that you were still not sure about. You don't quite understand the definition, the notation, or what have you. So go ahead and write that down on your template that we gave you in class. Now, if you got everything that we told you, maybe you want to write a discussion question. So something that maybe you think Ms. White or I would ask in class that would prompt the class to discuss it, or something you just want to know a little bit more about. You're not confused, but you thought it was a cool topic. Lastly, if you got everything, you don't really want a discussion, but you want to challenge your friends, write your own practice problem to bring to class and have your classmates figure out on their own. And you're going to do this after every lesson. Now, keep in mind, the reason we're doing flipped classroom is so that you guys can watch at your own pace. Like Ms. White said at the beginning, you can rewind, you can pause it, you can re-watch it. So if there's anything you missed, go back and watch it. If when we get to test day or right before test, you can feel free to pull up any of the lessons prior to it, re-watch them, or just the parts that you need. Okay? So again, if you had any questions, star them while you're taking notes. Make sure you paused and practiced, and make sure you rewind and re-watch if necessary. All right, we will see you guys in class.
See you in class.